Tonight, step outside. Find the darkest sky you can and look up. You'll see hundreds of stars, maybe thousands. Beautiful. But here's a question that completely changes what you are looking at. If the universe is filled with stars and stretches forever, why isn't the entire night sky as bright as the sun? For centuries, nobody had the answer. This mystery became known as Olbers Paradox. Imagine an infinite universe, stars scattered in every direction. Now pick any tiny point in the sky, just one tiny patch of darkness. If you look far enough along the line, eventually your view should land on a star, maybe nearby, maybe unimaginably distant. But a star. If that's true for every point in the sky, then every point should glow. Night shouldn't exist. Yet, every evening, darkness returns. Why? The obvious answer is that distant stars are just simply too faint. But that's only half of the story. Yes, light gets weaker with distance. A star twice as far away appears 4 times dimmer. But a shell of space twice as far away is also much longer, which means it contains more stars. Enough stars to perfectly cancel out the dimming. So, every shell of the universe contributes roughly the same amount of light. Add infinitely many shells together, and the night sky should become infinitely bright. Distance was never the answer. The real answer is time. The universe is about 13.8 billion years old. Light travels incredibly fast, the fastest thing in the universe. But it still needs some time to cross the vast distance of space. At the same time, the universe itself is expanding. As galaxies move farther apart, the space between them stretches. And as light travels through the expanding space, its wavelength stretches too, shifting towards redder and eventually invisible wavelengths. This effect is called redshift. Now, combine those two facts. Some stars and galaxies are just too far away that their light just simply hadn't had enough time to reach Earth. Others are so distant that, as their light travels through the expanding universe, it gets stretched out of the visible spectrum entirely. So, we don't see an infinite universe. We only see the part whose light has had enough time to arrive, and whose light hasn't been stretched beyond what our eyes can detect. The finite cosmic bubble is what we call the observable universe. So the next time you are looking into the dark night sky, you are not looking into an empty space. You are looking at the limits of the universe. A simple question, why is the night sky dark, revealed one of the deepest truths in modern cosmology. The universe has a beginning, and the space is being stretched out since then. Stay curious.